Hello and welcome to TI Now here at Cable-Tec Expo 2017 in Denver, Colorado. The topic of today's panel is deep fiber and network evolution. Here to help us understand the role of deep fiber in evolving networks are Sophie Legault, Director of Transport and Datacom with Expo, and Dr. Eugene Dye, Principal of Transport Architecture, Cox Communications. Welcome to you both.
Thank you. Thank you.
Dr. Dye, let's start with the basic question. What do people mean when they refer to deep fiber?
So that's a good question. And in order to understand that, we have to look at the current architecture of our access network. So the access network consists of trunk fiber from CEO head end to somewhere in the field. At that point, converts into electric signal, then send to the copper network. And for telco, that would be twist pair phone line. For cable operator, it will be coaxial cable. So the problem with this kind of network today is the bandwidth. The bandwidth inconsistency. You look at the fiber, their bandwidth, spectrum bandwidth is about terahertz. And the bandwidth of twist pair is about megahertz. And the bandwidth of coaxial cable is about gigahertz. So the copper part is the bottleneck of the network. And the other characteristic of this network is the copper network, the longer, the lower its useful bandwidth. So in order to increase the bandwidth to the customer, normally one solution is to shorten the distance of the copper. If you get the distance of copper, network is shorter than before. You got customers still connected, they're two-way. One is you extended the fiber. The other way is you move your customer's house close to the head end. Certainly, make the fiber longer is more easy. And that's what we mean by deep fiber.
So if we hear a lot about network innovation on the virtualization side and on software, what's the importance of network innovation in the physical network?
Well, and we're talking about fiber deep. The fiber part is a critical aspect of the network. It's actually the foundation of the network, and it'll basically become the backbone of that network. You were talking about bandwidth. The fiber is the medium that'll bring that bandwidth, that'll bring that augmented service to the end user. So if we look at for CATV MSOs, the legacy DOCSIS technology will not be able to meet that bandwidth demand over time. We'll see when that happens, but definitely it will not meet when it comes to time. So fiber is the base of that, and it also is the future-proof is for all future services, such as going to 5G or any future services as well.
Eugene, we hear all these new technologies and innovation in the network. How are we going to maintain 5.9 reliability given all this change?
So as the technology evolve, we see the technology tend to be more complicated. On the other hand, it brings more bandwidth. In that case, we have more room to do the error correction. So you can put a big fact code into your protocol. In that case, you will have more ability to correct the error. In that case, you increase your reliability of your network. So on the other side, the new technology could make one part complicated, but will make the other part simpler. One example is coherent communication. So before the coherent communication, we have to do the dispersion compensation on our network. At 50 kilometer span, we need to do dispersion compensation, and all the way to a few thousand kilometers. Now use coherent technology, on the protocol part, on the ASIC part, on the DSP part is more complicated, but it makes network design simpler. On a few thousand kilometers, we don't need dispersion compensation fiber anymore.
Yeah, and if we come into the context of fiber deep, bringing the fiber deeper, making it more digital rather than analog today, that brings more scalability, more flexibility to the network. So it allows the MSOs, the CATVs to offer services that can be equivalent or even better than the traditional carriers today, so they can compete for those demands and for those customers.
So if one could argue that the more complex these networks, the more service demand for them, the more demand for higher quality services, the need of network assurance, service assurance really comes into the foreground. Can you talk a bit about that and what has to happen in service assurance?
Yeah, it is very important from to do service assurance as part of the deployment and as part of the new technology. I wouldn't say there's more service assurance or more testing required. I'd say it's smarter testing, smarter service assurance that makes the technician and the operations center more efficient. The key thing is really to be able to measure the quality of experience of the user from his residence, from his business, to see their quality of experience. If you don't measure it there, then you don't have that visibility. So tools that are very simple to use, that actually automate the process, either it's deployment or also automate the service assurance part, the 24/7 monitoring, are key to that, and making things simple. That's what technicians, field personnel want. They want simple tools, but they are advanced from a technology perspective. That's key.
Dr. Dye, when you think about possible impediments to the adoption of deep fiber, what are they? Either from a marketplace perspective or technologically?
So basically, the real challenge to deploy the deep fiber is basically we have to understand the role and the function of the deep fiber in our network evolution. So we consider the deep fiber is the step leading to the FTTH, leading to the all fiber. So when we evolve to the deeper fiber, how deep the fiber should be. After we move the fiber node deeper for a while, so we move deeper and deeper. Every time you do this, you need, it comes with a cost. For example, from DOCSIS 2.0 to 3.0, we need to change the cable modem CPE. From 3.0 to 3.1, we need to change the CPE, as well as we need to retouch our outside network. From 3.1 to 4 duplex DOCSIS, we also need to change both CPE and the network. So to move in your fiber one step deeper, then you need to change your network. So we really do not want to do this a lot. So we want from the technology will enable us to fully use the bandwidth of the copper as a trace pair or the coax, then lead us directly to the FTTH.
Yeah. And there's also what we're seeing with our customers as well, is there's an operational challenge to that deployment of fiber deep. There's more requirement for knowledge of fiber, and also the cost of operationally deploying these networks is very high. So the return on investment has to be there, has to come quick, as opposed to augmenting the existing DOCSIS network. So again, things like automation and simplicity, and also knowledge of fiber by the workforce, by the operational teams is critical, and having the right tools is also very important there.
Thank you both for joining us today.
Thank you.
you.
Thank you.